In this video, we're going to be looking at probability of dependent events. So dependent events are when the occurrence of one event does affect the occurrence of the other event. So for example, drawing 2 marbles out of a bag without replacement. So if that previous problem, if we took out that marble and we didn't put it back, that's going to affect the probability of the next marble that we draw because I didn't replace that marble back in there. I can't choose it again. And then conditional probability is the probability that event B occurs given that A has occurred. And we rewrite it like this, and we read that as the probability of B given A. And so we can find that probability if events A and B are dependent events, then probability of A and B is equal to the probability of A times the probability of B given A. So let's look at some examples. So let's look back at one of those previous problems when we're trying to determine whether events were independent or dependent, or independent or not. And so that was this number 1, which again says a group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Find the probability of selecting a girl first and selecting a girl second. So I'm going to label my events first. So I'm going to have that A is girl first and B is girl second. And so first I want to find on this equation here, I want to find the probability of A. So I want to find the probability of getting a girl first. And so if I go back to that problem where we are looking at, we found that probability of girl first was 9/12. Which is equal to 3/4. And then I want to find the probability of B given A. So probability of B given A, so probability that a girl second given that the girl was chosen first. So looking at my sample here, that's going to be these 6 options right here of where the girl is first and second. And so I see that's 6 different options out of 9. And I get the 9 because there's 3 more options here where the girl is first and instead the boy is second. And so that means that the probability of A and B is equal to the probability of A times the probability of B given A. So I have 3/4 times 6/9, which ends up being 0.5. So you have a 50% chance. Okay, let's look at another one. So this one says that a bag contains 20 $1 bills and 5 $100 bills. You randomly draw a bill from the bag, set it aside, and then randomly draw another bill from the bag. So here the key word is that you set it aside. So you're setting aside, that means you're not replacing it without replacing it. So I know this is dependent. I want to find the probability that the first bill is $100 and the second bill is $100. So I'm going to label my events. So A is first bill is $100 and event B is that my second bill is $100. So I first want to find the probability of A. So I want to find the probability that my first bill is $100. Well, I see that the bag contains 5 $100 bills, so I have 5 on top. Over the total number of outcomes, we'll have 20 $1 bills and 5 $100 bills. So that means the total number of bills I have is 25. which if you reduce that is equal to 1/5. Then I want to find the probability of B given A. So I've already chosen the first bill. The first bill is $100. So that means I have one less $100 bill. There's only 4 in there. And I have one less total bills. So that means that my number of successes is going to be 4 because I've already chosen one of them. And my total is also going to be 1 less. And if I simplify that, that's 1/6. And so I get that the probability of A and B is equal to the probability of A times the probability of B given A. And so that is 1/5 times 1/6, which is 1/30, which is approximately 0.033. So you have a 3.3% chance.